An equalizer, or an EQ, allows you to boost or cut specific frequencies of audio. Reading the EQ graph is easy, with a horizontal line showing the frequencies that you are adjusting and the vertical line showing how much you are boosting, increasing, or cutting, decreasing the selected group of frequencies. The horizontal line represents the audible range of our hearing, 20 Hz to 20,000 Hz, or 20K. This brand of equalizer has a spectrum analyzer which displays the signal of audio as it relates to frequencies. If I make a hissing sound, you can see the high frequencies on the right side. If I make a tonal sound like woo, you can see the frequency of the tone that I am generating. All EQs, whatever the brand, have the same basic layout. By the way, do you know the highest frequency that you can hear? As we get older, we lose the high end of our hearing. Back to the EQ. If you would be boosting 6 dB at 500 Hz, you would use your mouse to drag the dot around 500 Hz and boost it up plus 6 dB. Now, all of the frequencies in the slope will also be increased based on the bell curve of the slope. Fully parametric EQs, like this one, enable you to narrow or widen the bandwidth like this. The wider the band, the more frequencies you are boosting or cutting. The narrower the band, the less frequencies you are boosting or cutting. You may be familiar with graphic equalizers that have sliders on a fixed frequency and an invisible fixed bandwidth. On the left and right side of the EQ is the high and low shelf that will boost or cut from the frequency selected to the top end or bottom end of the equalizer range. The high shelf sounds like this when I cut or boost, and the low shelf sounds like this when I cut or boost. Most EQs come with a high-pass filter and a low-pass filter. A low-pass filter will filter out the high frequencies based on your selection and pass the low frequencies that are left in the frequency range. A high-pass filter will filter out the low frequencies based on your selection and pass the high frequencies that are left in the frequency range. A combination of a low-pass and the high-pass filter creates a band-pass filter, only passing the band of frequencies left. This filtering is often used to create the sound of a telephone, since a telephone does not reproduce all of the frequencies in the range of our hearing. The difference between a shelf and a filter is that a shelf will cut or boost from the frequency selected, and a filter will eliminate from the frequency selected. Since this is a book, website, or video about audio post-production, a lot of EQing happens with dialogue, the priority in mixing films, TV, and all media. What I strive for is clarity in dialogue, and this is a very brief generalization of how I go about it. EQing is mostly about removing the ugliness of the sound. In my voice, since I am recording on a large diaphragm microphone, speaking in close proximity to it, my voice has a lot of low frequencies, usually the resonant frequency of my torso. The first step I usually take is to reduce those low frequencies by first finding the frequency center by boosting it and scrubbing left and right until I hear the loudest frequency, and then cut that frequency a little bit using a moderate bandwidth. Reducing my resonant frequency, my fundamental, clears up the speech. I may also want to boost a little of the high frequencies. I typically select around 5 to 10K with a wide bandwidth. I do not want to make me sound too thin with the EQ, but to make it clear and easily understood. Again, for me, EQing is mostly about reducing the frequencies that I do not like. For example, with dialogue, I tend to filter out the frequencies that are below speech by using a high-pass filter. While I was recording this video, I have been EQing my voice so you could hear the difference while I make adjustments. This is the sound of my voice with the EQ. This is the sound of my voice without the EQ. Again, this is my voice with EQ. And this is my voice without my EQ choices.